So here we're looking at a practical based question. That is, I've done this practically. All these values are an actual value. Okay, so let's verify what we understood till now. Let's verify the formula and let's verify if it actually works. Right? It's basically verification and understanding and everything put together. I have a few set of questions. So I have a real image. If the real image, as you can see, is a real image. So what is the real image? One which can be captured on the screen. So if the real image distance is approximately 58 centimeter. So I got an image on the screen which is approximately 58. So you can see here, this is 50 and this length approximately, I think this is perpendicular, right? This is around 50, beyond 58, 58-ish. Okay. Find the object distance. So we have to find where the object is actually. That also I'll be showing you where it is and we can verify what calculation with the calculation part. So is the calculation and the actual thing, do they match? That's the question which we are trying to answer. So it's an exposure to you guys that yes, you guys can actually get the image if you know the focal length and the uh, object distance. Okay, you can actually get to know where the image can be formed. So with all of this calculation is how you build a projector. That's how you build a telescope and everything. Okay, so all this is practical. Okay, so given the converging mirror, radius of curvature is approximately 34 centimeter. So my request is pause. It's a simple question, simple formula, substitute, use calculator. You need not do all the calculation, use calculator and calculate. Okay, I'll do it now. So we have a real image and we have a converging mirror. So let me just draw a small diagram which helps us to understand and do this. So this is your concave mirror. So we have the focus and center of curvature. So we have a real image which is 58, right? So real image and all that, it's supposed to be on the left. I exactly don't know where it is. Actually, I do know. It's behind the center of curvature, 58, right? So behind center of curvature. And by the way, this is concave. Reason being, it's a converging mirror and it forms real image, right? I hope you guys were able to put all of this together. So the radius of curvature is 34 centimeter. So this will be 17 centimeter away from the pole, focus and center of curvature. Now you have given, what is given guys? V, which is minus 8 centimeter approximately. Remember, F is not minus, R by 2. So this is minus 34 by 2. Remember why minus? Because center of curvature focus is on the left. So we are taking it to be minus 17 centimeter. So what is that we have to find? We have to find V, sorry, U. And we know the working, the formula and everything. It's quite simple. I hope you guys use the not formula, calculator. 1 by V plus 1 by U. So 1 by minus 17 minus 1 by 58 plus 1 by U. So therefore 1 by U is equal to minus 1 by 17 plus 1 by 58. Right? Simple calculation. Don't get confused. So let us do the calculation. 1 divided by 58 minus 1 divided by 17. Okay, so this is 1 by U is 0.0416. 1 by U is 0.0416 minus, by the way. Still, we are yet to find U, which is inverse of, no, that is not it, 1 divided by 0.416. 24, 24, right? This is approximately 24. 24.00 centimeter. All this is approximated. Okay, you can clearly see my photo and my setup is not that exact. Okay, by the way, minus, don't forget that it's a real image. Now, this is your practical answer, guys. This is where I have kept the object. Can you see that? So let us take the 24 length. Okay, so I mean, it's a bit away from 24 actually. This is the object actually, right? A few centimeter. Ah, it's closer to 25 to be honest. Anyways, but we can see that my measurement, this taking us 58 was, maybe we should have taken it a bit more or a bit less. This is not the exact value. 34 is, I think this is also not exact value of the mirror's radius of curvature. So put together, an error will come plus or minus few percentage. And for us, for the setup we have, this is okay. Okay. So yes, the question was, do we actually get the actual values and the real values, calculated values and the real thing? Do we actually get it? So answer is yes. You can actually set up things and you can actually get to have a look at it. Okay, so you can calculate and you can keep the screen at a particular point and you will get an image, right? So all this is practically possible, and this is not just for the sake of learning, it is practically possible. So you guys can also try this. Simple concave, convex mirrors and lenses you guys can buy, and simple setup. You can use candle instead of a bulb. I use a bulb. And all this cutting, you can make this also. It's not too hard. You guys, I'm sure you guys can do this. So all this can be done in your school, at your house, or you guys as a group. You guys can do this and learn better. Okay, so that's the point of this question and showing all of this, right? So you guys can pause and make a running note, or you guys want to write something, you can write down.